Hello. Ma'am, let's start the program, ma'am, please.
Okay. A pleasant morning to you all. I welcome you all for the 6-day faculty development program on emerging innovations in chemistry and chemical technology 2023. I would like to call Dr. S. Chandrasekharan, convener of this program, associate professor and head of chemistry, Arasu Engineering College, Kumbakonam, to deliver the welcome address.
Thank you, ma'am. Good morning to you all. It's my immense pleasure to welcome you all for this inaugural ceremony of 6-day faculty development program on emerging innovations in chemistry and chemical technology. I take this wonderful opportunity to welcome our principal sir, Dr. T. Balamurugan, Vice Principal ma'am, Dr. Kalaimani Shanmugam, Dean of Academics, Dr. Rukmanandan sir, HODs and faculty members of various departments on this occasion. I wholeheartedly welcome our resource persons individually, Dr. T. Marudavanan from Sona College of Technology, Salem, Dr. M. Kumaresan from Nehru Institute of Technology, Coimbatore, Dr. P. Periyasamy, Assistant Professor, Nehru Institute of Engineering and Technology, Coimbatore, Dr. S. Ramasubramanian from Amrita Vishwa Vidyapeetham, Coimbatore, Dr. P. Manikandan, Kongu Engineering College, Perundurai, and Dr. T. A. Sugandha from KS Rangasamy College of Technology, Tiruchenkodu, for this FDP inaugural ceremony. It is my great delight to welcome you all, the faculty and research scholars of various institutions from Tamil Nadu and other states of India as participants in this unique forum. I extend my welcome to all the learned members of who are all connected in this forum, each and every one of you at this juncture, and thank you for this wonderful opportunity to welcome you all. Thank you.
Thank you, sir. Now, I would like to welcome our Honorable Principal, Dr. T. Balamurugan, Arasu Engineering College, Kumbakonam, to deliver the presidential address.
Respected resource persons of this faculty development program, organizers, participants, a very good morning to you all. I am very happy to preside over the inaugural ceremony of the 6-day faculty development program on emerging innovations in chemistry and chemical technology by the Department of Chemistry of our college, by having Dr. T. A. Sakunda from KS Rangasamy College of Technology, Tiruchenkodu, Dr. Kumaresan from Nehru Institute of Technology, Coimbatore, Dr. T. Marudavanan from Sona College of Technology, Salem, Dr. P. Periyasamy from Nehru Institute of Engineering and Technology, Coimbatore, Dr. S. Ramasubramanian from Amrita Vishwa Vidyapeetham, Coimbatore, and Dr. P. Manikandan from Kongu Engineering College, Perundurai Road as the resource persons. Normally, the day-by-day expectations of the living being is getting updated and getting increased. So in order to satisfy the day-by-day expectations, we have to adopt new technologies because there is no saturation for the expectation. The day-by-day expectation is getting increased. So in order to satisfy, we have to apply the latest and new technologies. So for that, we have to cope up ourselves with the updations. Otherwise, we will become outdated. So for this, now the organizing such type of events will give idea about the latest technology to the researchers so that they can adopt this technology for the satisfaction of the expectations. So my dear participants, today we are having eminent persons, those who are dealing the latest technologies in that particular field as the resource persons. So it's a very good chance given to you to get the latest updations and innovations in the particular field from our resource persons. So try to effectively utilize this opportunity, having a very good interaction with our resource persons. So if you have a very good interaction with our resource persons, definitely you can gain a lot from their experience and expertise. So with this request, I try to effectively utilize this opportunity so that the objective of the program will be getting fulfilled. So with this request, my best wishes for the successful conduct of this event. Thank you.
Thank you, sir. I would like to invite Dr. M. Rukmagadan, Dean of Academics, Arasu Engineering College, to felicitate the program.
Respected resource person of this program, respected principal, vice principal, HOD and staff members of chemistry departments, and participants from various colleges. Good morning to all. Today I am feeling very happy by hearing that the Department of Chemistry is organizing a 6-day faculty development program on emerging innovations in chemistry and chemical technology. The resource persons involved for this FDP program are much more expertise in the field of chemistry and chemical technology. We know that there are plenty of research works to be carried out in the various fields of chemistry and chemical technology. So I hope that this faculty development program will be definitely useful to all the participants to carry over research in their respective areas. For that, I appreciate the HOD and the staff members of chemistry departments for organizing such faculty development program at this time. So I request all the participants to make use of this faculty development program in a fruitful manner by having good interaction with our much more expertised resource persons. And finally, my best wishes to all the participants and grand success of this faculty development program. Thank you so much. Thank you.
Thank you, sir. I would like to invite Mrs. T. Parimala, Assistant Professor of Chemistry, Arasu Engineering College, Kumbakonam, to introduce the resource person.
Very good morning to all. I am very happy to introduce Dr. T. Marudavanan, Associate Professor, Department of Science, Sona College of Technology, Salem. Our resource person has completed his graduation and MPhil from Annamalai University, Chidambaram. He has received PhD from Annamalai University, Chidambaram. He is serving in teaching community after his PhD program, and he has 23 years of research expertise. He has published more than 24 research articles in national and international journals, and he has published 14 books and also 47 research papers. He has attended more than 50 FTP workshops and conferences, including national and international. At this juncture, I desire to note that he has produced 35 scholars in MSc, 16 scholars in MPhil, and 2 scholars in PhD. Currently, he has been guiding 2 PhD candidates. He received many awards, including Best Academic and Research Excellence several times. It's our privilege to have such a wonderful personality as a resource person in today's FTP. I wish to thank you all for providing this opportunity to introduce such a great personality. Thank you once again.
Thank you, ma'am. This is our pleasure and honor to invite our resource person, Dr. T. Marudavanan, Associate Professor of Chemistry, Sona College of Technology, Salem, to deliver the keynote address. Please, sir.
Good morning to one and all present here. Am I audible?
Yes, sir.
Yes. First of all, I wish to thank the management and the principal of Arasu Engineering College for giving me the wonderful opportunity to share my thoughts in the area of organic electronics. I wish to thank my dear friend Dr. Chandrasekharan for giving me the opportunity. Is it visible, my slide?
No, sir.
Sir, it's muted now.
Okay, right. I wish to introduce myself as I am Dr. Maradavanan, Associate Professor Chemistry. I am working in this college for the past 19 years. My area of research is synthetic organic chemistry and environmental chemistry and nanomaterial synthesis. Here in this FDB program, I am going to talk about organic electronics, emerging materials for electrical and electronic device fabrication. And nowadays, organic electronics became a very emerging field because due to low-cost materials, these organic electronic materials are replacing the existing conventional materials in various device fabrication. Nowadays, we are using different types of electrical and electronic devices with using some conventional materials like inorganic materials or silicon or germanium-based semiconducting materials. Due to high cost and maintenance, we are in need of some alternate materials. Okay, therefore, this organic electronic materials plays a vital and important role in the fabrication of electrical and electronic devices. In my presentation, I am going to give introduction about organic electronic materials, how it is working, and construction and working principle and applications of organic semiconducting materials, organic dielectric materials, organic light emitting diodes, that is OLED, and organic transistor, and lastly organic solar cells. Introduction of organic electronic material. Organic electronics refers to organic, that is non-metallic materials that exhibit semiconducting properties. These organic materials may be small molecules, short chains of molecules, and long polymeric chains. The semiconductivity in these materials is due to the delocalization of pi electrons. Organic semiconductors are based on the unusual properties of carbon atom. Normally in insulator, carbon atoms are linked together by only sigma bonds through sp3 hybridization. Gap between occupied bonding orbitals and the unoccupied antibonding orbitals leading to properties. These bonds have large gap between the highest occupied molecular orbital, that is shortly known as HOMO, HOMO, and the lowest unoccupied molecular orbital, LUMO, LUMO, leading to the well beyond visible spectral range. In semiconductor, the carbon atoms linked together by alternate pi bonds through sp2 hybridization, that decreasing gap between occupied bonding orbitals and the unoccupied antibonding orbitals, leading to semiconducting properties. These bonds have much smaller energetic difference between the HOMO and the LUMO, leading to strong absorption in or near the visible spectral range.
Excuse me, sir.
Yes, ma'am.
Yes, sir. Your screen is not visible to us, sir.
Yes.
Yes.
Is it visible now?
Yes, sir. It's visible.
Please wait, I have some problems. Is it visible now?
Yes, sir.
Okay. Right. Organic small molecules or oligomers or polymers containing alternate pi bonds show semiconducting property due to the delocalization of their pi electrons as shown in the following figure. Because of this conductivity, these kind of organic materials are considered as non-metallic semiconductors. Because of this property, the organic molecules are used to fabricate the organic electronic devices. Here in this slide, you can see the organic compound containing alternate double bonds. That is, due to this alternate double bonds, there is a possibility of delocalization of pi electron in some organic compounds. In the first picture, you can see the alternate double bonds, and due to the delocalization, the electron will revolving around the compound. First one, we are going to see organic semiconducting materials. Usually, hole transporting, that is P-type semiconductors, have been prepared from electron donating pi systems, whereas electron transporting, that is N-type semiconductors, are prepared from the electron accepting ones. Types of organic semiconducting materials. There are two types of organic semiconducting material. One is P-type and N-type. Organic semiconductors are widely classified into two types based on their majority of charge carriers in the system. P-type holes are the major charge carriers, that is the pi conjugated organic molecules with high electron donating in nature belongs to P-type. N-type semiconductor, electrons are the major charge carriers, that is the organic molecules with high electron accepting in nature belongs to N-type. Here you can see in this slide, there are two examples for P-type semiconductor and N-type semiconductor. The example for P-type semiconductor is pentacene. In this picture, you can see 5 phenyl rings are attached together, and it has an alternate double bond. And another compound is poly-3-hexyl thiophene. Okay, these two compounds are example for P-type semiconductor, P-type organic semiconductor. And in the second picture, you can see the fullerene. It is a buckyball, so that is C60. It is a allotrope form of carbon. Here in this hydrophilic fullerene derivatives with glycolated side chains are promising materials for efficient N-type. Here now we are going to see the working principle of P-type organic semiconducting materials. The very best example for P-type organic semiconducting material is pentacene. Pentacene is a polycyclic aromatic hydrocarbon consisting of 5 linearly fused benzene rings. This highly conjugated compound is an organic semiconductor. The compound generates excitons upon absorption of ultraviolet or visible light. This makes it very sensitive to oxidation. For this reason, this compound, which is a purple powder, slowly degrades upon exposure to air and light. Here in this picture, you can see the structure of pentacene. Second type of organic semiconducting material is N-type semiconductor. The example is fullerene. A fullerene is an allotrope form of carbon whose molecule consists of carbon atoms connected by a single and a double bonds to form a closed or partially closed mesh with fused rings of 5 to 7 atoms. The molecule may be a hollow sphere, ellipsoid, tube, or many other shapes and sizes. Graphene, that is isolated atomic layers of graphite, which is a flat mesh of regular hexagonal rings, can be seen as an extreme member of the family. Fullerenes with a closed mesh topology are informally denoted by the empirical formula Cn, often written Cn, where n is the number of carbon atoms, but normally these fullerenes are termed as C60. Next slide will give the difference between organic and inorganic semiconductor. We already studied about inorganic semiconductor, that is silicon and germanium based. But here we are comparing that inorganic semiconductor with our organic semiconductor. First point is free carriers in the form of electrons and holes. In the case of organic semiconductor, do not support free electrons and holes. Second point, Vanier mode type excitons, that is small binding energies. Here you can see the structure. And in the case of organic semiconductor, Frenkel type excitons, large binding energies. Therefore, in the case of inorganic, dissociate easily into free electron. And in the case of organic, it is impossible to dissociate the free electron from the nucleus because the diameter is very, very low when compared to inorganic. Much smaller effective mass of carriers of that in organic. In the case of organic, much larger effective mass of carriers of that in inorganic. Fourth point, higher mobility for charge transport, but for organic semiconductor, low mobility for charge transport. Band mechanism for charge transport is possible in inorganic semiconductor. Hopping mechanism for charge transport is seen in organic semiconductor. The difference between valence bond and conduction band is called as band gap. But in the case of organic semiconductor, difference between highest occupied molecular orbital, that is HOMO, and the lowest unoccupied molecular orbital, LUMO, is called band gap. Here the conductor is free electrons, but here the conductor is pi electrons. Therefore, here you can easily find the difference between inorganic semiconductor and organic semiconductor. In inorganic semiconductor, the conductivity is due to the free electrons. But in the case of organic semiconductor, the conductivity is due to the delocalization of pi electrons. Now we are going to see what are the advantages, why we have to use organic electronic materials for the device fabrication. First one, availability. Organic materials are synthesized from cheaply available resources such as crude oil and plant materials. Second one, cost. Large quantity of organic materials can be produced with cheap cost because crude oil resources are available much more when compared to inorganic based materials. The organic materials are very cheap. Then material usage. The materials required to fabricate the electronic devices such as organic solar cells and light emitting diodes is only fractions of a gram of organic materials. But in the case of inorganic, that is silicon and germanium, it requires more. Then flexibility, very, very important property of this organic electronics. Since very thin layers, that is below 1 micrometer of material only are needed, the electrical components are inherently flexible and bendable, just like a plastic foil. Additionally, organic materials are soft rather than porous, which means that they can be bent without breaking. This advantage can be utilized when, example, printing an organic solar cell onto plastic foil so that it can be rolled up as needed. Due to this flexible behavior of this material, we can roll it in any shape. Next point, production. Organic optoelectronic devices are fabricated relatively easily and without much energy usage. In particular, the production does not involve high temperature process, which require a lot of energy and much sophisticated fabrication techniques. The last, the important point in this fabrication of organic material is encapsulation. To protect the damage of devices by environmental influences, organic electronics components have to be encapsulated. For example, they can be encapsulated between Audience, are you visible my slide?
Yes, sir.
Organic dielectric materials. Have you seen my previous slides, organic semiconducting materials? Hello? Am I audible?
Yes, sir, audible.
Okay, sir. Right. Okay, then the second one is organic dielectric materials. Here you can see when the dielectric materials is placed in external electric field, the molecules are oriented and aligned themselves. The example for this organic dielectric material is polystyrene. The dielectric constant is 2.6. And another organic dielectric material is polymethyl methacrylate, PMMA. The dielectric constant for this PMMA is 2.8 to 4. The slide is visible.
Yes, sir, visible.
Okay. Various organic in this slide you can see there are so many organic compounds listed in this table. First one is polyimide. The dielectric constant is 2.6. Then polyvinyl phenol, P4VP, PS polystyrene, P3DDT, PVA. And the last one you can see the compound, it has the highest dielectric constant, 10.3. Next compound is the organic light emitting diodes, shortly known as OLEDs. Okay, here in this picture you can see it is a cross section of organic light emitting diodes. The working principle of OLED is when a voltage is applied to the electrodes, the charges start moving in the device under the influence of the electric current. Electrons leave the cathode and holes move from the anode in opposite direction. The recombination of these charges leads to the creation of a photon at the emitting molecules. Here the electrical power applied to the electrodes is transformed into light. Therefore, this is the basic principle of this organic light emitting diode. In the above device, the emissive layer has a key function and the other layers are introduced to improve the efficiency of the device. Generally, the organic compound with electron donating nature used as a hole transporting layer, and the organic compound with electron accepting nature used the electron transporting materials. The next one, the components of organic light emitting diodes. First one, light emitting organic material has main emissive layer. Second one, hole transporting layer. Third one, hole injection layer. Fourth one, electron transporting layer and electron injection layer. And sixth one, anode and cathode. The construction of organic light emitting diodes. Organic light emitting diode is a flat light emitting technology made by placing a series of organic thin films between two conducting metal electrodes. When electrical current is applied, a bright light is emitted. Typically, at least one of these electrodes is transparent. Here in this picture, you can see the organic light emitting diode. In the bottom, you can see ITO, indium titanium oxide substrate material. And above this P.PSS, this organic conducting polymer of 40 nanometer size. Then above this EML layer and the electron transporting layer, and above this cathode is constructed. and cathode and anode is connected, and if the external electric field is applied, we can get a bright light. If you want to blue light, we have to use blue OLED material, that is ALQ2OP. If you want to green color light, you have to use a green OLED material ALQ3. And if you want to red OLED red light, if we should use a red OLED material, that is TPP, thiamine pyrophosphate. Okay. If you want to a bright white light, we have to combine all these three colors. Okay, blue, green, and red. Then applications of OLEDs. OLEDs are used to create digital displays in devices such as television screens, computer monitors, large screens in auditoriums. Nowadays, we are using different types of display devices. Especially in our home, we are using LED TV. And nowadays, the companies like Samsung, LG, and other brands, they are using organic light emitting diodes in the manufacture of these products. Used in all types of portable systems such as mobile phones, digital camera players, car radios, digital cameras, car lighting, handheld games, and PDAs. Such portable applications favor the high light output of OLEDs for readability in sunlight and their low power drain. Intense research has yielded OLEDs with remarkable color accuracy, device efficiencies, and operational stability. For developing white OLED, three different dyes, that is blue, green, and red, are mixed into one single emission layer. Okay, we can produce colored light as well as the white light by using this OLED device. If you want to separate a particular color light, blue, red, or yellow, we can use different compounds. If you want to produce a perfect white color, three different dyes of compounds to be used. The highest degree of freedom in terms of color and efficiency tuning is achieved by doping all emitters into one single layer. In this case, a homogeneous white emission is achieved by adjusting the concentration of the individual dyes. The advantages of OLED is first, robust design, variety of portable devices. We can manufacture different types or different size of devices by using this OLED material. It covers high viewing angle. It is a very important advantages of using organic light emitting diodes. If organic light emitting diodes are used in any display devices, it gives very high viewing angles, that is 160 to 170 degree, which is not possible in the conventional materials. High resolution, it is also very important. You can see crystal clear picture. You can see you can compare the picture from normal TV and OLED incorporated TV. The crystal clear picture you can see in the case of organic light emitting diodes. Cost of production is 20 to 50% cheaper than LCDs. It is lighter and faster. Power usage less due to no lighting source. These are all the main advantages of organic light emitting diodes. Here in this picture, you can see the Samsung and the LG company, they are using organic light emitting diodes materials in the display unit. Here, if you see the pictures or any movies by using this kind of televisions, you can witness a high clarity picture and movies. We can compare the OLED and LCD. LCD means a liquid crystal display. In formerly we were used this kind of LCD TV, but nowadays there is no LCD TV. All the LCDs are transformed into LED TVs. The table will give the difference between OLED and LCD. In the case of OLED, greater view angle is possible, but in the case of LCD, only limited view angle. OLED gives high contrast. LCD gives only low contrast. In OLED, faster response time. That is, if you want the television, immediately it gives signal and it operates very slow. Slow response in the case of LCD. OLED do not require backlighting, but in the case of LCD, it requires backlighting. Okay, these are all some advantages of organic light emitting diodes used in the all kind of display devices. Next, we are going to see organic transistor. Okay, so far, we have discussed organic semiconducting material, organic dielectric materials, and organic light emitting diodes. Next one, the organic transistor. An organic transistor consists of semiconducting layers that are merely composed of organic electronics material. An organic transistor basically consists of the following different components. Normally, all kind of semiconducting materials, dielectric materials, and LEDs are same working condition, same principle with the existing conventional material. The only thing is we are changing the material. Instead of using inorganic based materials, we are using different types of organic conducting polymers in this device. So here in this picture, you can see there is a source and a drain. In between, you can see the semiconducting materials are incorporated, and the insulator is also there. The components of this organic transistor is a source and drain, electrodes, insulator layer, an organic semiconductor, and the substrate. Working principle of organic transistor is the basic functionality of organic transistors is very simple and comparable to thin film transistor, that is TFT. Without a gate voltage being applied, no current flows between the source and drain electrode, since the semiconductor layer is intrinsic and consequently non-conducting. Once a gate voltage is applied, a very narrow conductive channels forms on the semiconductor insulator interface due to the accumulation of charge carriers, so that current can flow from the source to drain. The current level depends on the gate voltage, which determines the number of charge carriers as well as on the charge carrier mobility, which in turn determines the charge carrier velocity. Therefore, in the case of organic transistor, we have to supply the gate voltage from a source to drain. Then only it will work. The advantages of organic transistor. Organic transistors are lighter and more flexible. It is very, very important advantage. It is not possible in the case of conventional materials. Conventional materials, they have their own weight, and they cannot be folded or flexible one. But in the case of organic transistor, they are light in weight and more flexible. They are low cost electronics. It is also very important for making electrical and electronic devices. No vacuum processing, no lithography, no printing is required, and low cost substrates. We can use plastic sheet or even paper or cloth for the fabrication of organic transistor materials. The last compounds, organic solar cells, or otherwise known as plastic solar cells. Nowadays, we are using solar cells, that is photo galvanic cells, for the harvesting solar power into electrical power. We are using different types of silicon and germanium based solar cells in our rooftops. But the disadvantage is the investment is very, very high. It requires very high investment, and it is not flexible one. It has a frame, it occupies more space. But consider these ambiguities. Scientists develop some organic solar cells, okay, to reduce the making cost and flexible one. Organic solar cells convert solar energy into electrical energy with low cost and flexible design.
சரிங்க சரிங்க கொஞ்சம் வெயிட் பண்ணுங்க.
English.
Dear
Dear
faculty,
faculty,
is it
is it
audible?
audible?
Okay, there may
Okay,
be
there may
some
be some
network
network
issues
issue
for the
for
resource
the resource
person.
person.
Can you
Can you
kindly wait
kindly
for a
wait
few
for a few
minutes?
minutes?
Definitely, we will
Definitely, we
share
will
the
share the
feedback
feedback
link at
link
the end
at
of
the
the
end of the
session.
session.
So
So
kindly wait
kindly
for
wait
some
for
time,
some time,
please.
please.
சார் நான் பேச கேட்டுதா? ம் பண்ண மாட்டேங்குது.
இந்த மாதிரி ஸ்பிளிட் அப் தான் நான் எதிர்பார்த்தேன்.
Sir, any questions, sir?
Madhavan sir,
Yes.
sir, the session is over.
Yes, sir. Yes, sir.
Okay, 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 sir. Please wait.
Sir, any questions from the audience?
Participants, dear participants, can you get any queries or any other discussion? Participants can ask any other doubts and queries is there.
Yes, ma'am. Satya, yes. Satya, do you have any question?
Good morning, sir. I'm Kavita from Arasu College.
Yes, ma'am.
Yes, sir. If you use organic molecules, if any kind of problems are arised,
Normally, organic compounds are very poisonous.
is it audible, sir?
Yes.
Okay.
But even though organic compounds are very toxic
Yes.
in nature, we have to take
Excuse me, sir. Voice break.
we have to take care of making
Yes.
during the in laboratory. We have to take more care during the preparation.
Okay, thank you, sir.
Okay, thank you. Any other questions?
Sir, somebody asked the questions in the chat box.
Yes.
Can you visit that?
Can you read the question, Chandrasekharan?
Yes, sir.
Yes, sir, I will read
Yes,
out.
please,
Sir.
please.
Okay.
What are the limitations of using organic semiconductor? That's the question, sir.
There is no limitation. All the organic semiconducting materials can be used, can be manufactured in our laboratory. There is no limitations. Since it is very cheap and more available one, there is no restriction. The second question, ma'am.
So there are only one question, sir. Is there any other questions to ask our resource person? Participants can utilize the discussion session. Ma'am?
Yes, sir.
Ma'am, please go on as per our agenda.
Okay, sir.
Thank you.
Now, I would like to call Dr. M. Vettuchelvan, Assistant Professor of Chemistry, Arasu Engineering College, Kumbakonam, to propose the vote of thanks.
A very good afternoon to all. It gives me great pleasure for proposing the vote of thanks in our faculty development program. First, I express my sincere thanks to our management, principal, vice principal, and dean of academics for their endless support to conduct this FDP in successful manner. I express my heartfelt thanks to our today's resource person, Dr. T. Marudavanan, Associate Professor of Chemistry, Sona College of Technology, Salem. On behalf of our management, Department of Chemistry, and participant for this deep insight on his title, Organic Electronics Emerging Materials for Electrical and Electronics Device Fabrication. On behalf of the Department of Chemistry, I show my gratitude to the technical team, system admin, and faculty of Science and Humanities for providing continuous support to organize the FDP successfully. I extend my thankfulness to all the participants from various institutions for registering in his FDP and people who are all communicated to their faculty and friends about this FDP. I hope all the faculty and researchers had a great time and informative session today. Finally, I thank you all for giving me the opportunity to express the vote of thanks. Once again, thank you all.
Thank you, sir.
Thank you very much, sir.
Yes, thank you, sir. Thank you very much.
Thank you, sir. Thank you, sir.
Thank you, everyone, for this session who contributed. Thank you very much.
Thank you, sir.
The feedback
leave
link
the
will be
meeting?
shared right now.
Chandrasekharan, shall I leave the meeting?
Sir, yes, sir, you can leave, sir. The feedback link is shared right now. Yes, thank you.
Okay. Okay, thank you.